In this video, we'll be doing integers in a fixed number of bits, or rather converting numbers or integers to binary. So we'll be converting your normal numbers, for example, 75 to binary, which will be 1001011. But worry not, we'll just go through the steps in a few. Firstly, it's important to know your powers of 2's. Remember, we always dealing with powers of 2's. Remember, we have our previous formula that we did for getting the number of possible combinations, which was 2 to the power of n, right? Yes, so now it's important for us to know powers of 2's. We need to know 1, 2, 4, 8, 16, 32, 64, 128, 2, 5, 6. So this is 2 to the power. This one. This is the result of 2 to the power of 0. This is the result of 2 to the power of 1. The result of 2 to the power of 2. 2 to the power of 3, and so forth. Okay, so these numbers are important. So there are two ways of converting numbers to binary. You'll just choose one that works best for you. We'll start with the subtraction method, right? Given that we want to convert 75 to binary, let's use a different color for that. We want to convert 75, right? So why are these numbers important? They're important because we use them for conversion. So when we want to convert 75 to binary, we're gonna go back to these numbers here, and then we check which number is the most less, the number smaller than 75. It's 64. I know that all these numbers are smaller than 64. Are smaller than 75. But then we're looking for the one closest to 75, right? Which is 64. Then we're going to come here and subtract 64, which will give us 11. And then we go back again. We look for the number that's smaller than 11, but closest to 11, which is going to be 8. So you're going to have 11 minus 8, which equals to 3. And then we're going to go again to these numbers. Look for a number that's smaller than 3, but closest to 3. And I have 3 subtract, which is equals to 2. Subtract 2, which equals to 1. So what I like doing here is that I'll just write 1. 1 is our last number that's smaller than 1. 1 is our last number, so we just put our 1 there. And then how are these numbers then now important? That means that we're going to start from 64 we're going to start from 64, 32, 16, 8, 4, 2, and 1. Remember, we started by subtracting 64, so that's where we're going to start, and then we write everything else, all the powers of 2's that are from 64 until 1. We write all of them, and then we go back here to our numbers that we were busy subtracting. So we check, is 64 one of the numbers that we were subtracting? Yes, it is. So we write 1. Is 32 one of the numbers we were subtracting here? No, it's not. So we write 0. Is 16 one of the numbers we were subtracting? It's not. We write 0. Is 8 one of the numbers we were subtracting here? Yes, it is. Is 4 part of the numbers? No, we write 0. Is 2 part of the numbers? Yes, it is. Is 1 part of the numbers? Yes, it is. And that is 75 written in binary. This is 75. Now we can quickly check if our answer is correct. Wherever we have our 1's, we take those numbers and add them. Just a little check here. 64, there's a 1 here, there's a 1 here, there's a 1 here, there's a 1 here. So we're gonna say 64. Sorry. We're gonna go ahead and say what's happening? We're gonna go ahead and say 64. Okay, this thing is acting up now. 64 plus 8 plus 2 plus 1. We know that 8 plus 2 is equals to 10. 10 plus 64 is 74. Plus 1 is equals to 75. So our answer is correct. Then we're just going to have another example where we will be converting an integer to binary. Let's see what we would like. We would like to convert 47 to binary, right? Remember our multiples of our powers of 2, which is 1, 2, 4, 8, 16, 32, 64, 128, 2, 5, 6, and so forth. Firstly, we go and look for a number that's less than 47 but closest to 47 from these numbers here that we just wrote down. It's going to be 32. So we're going to say 47 minus 32, which gives us 15. And then we're going to go look for a number that's less than 15 but closest to 15, which is 8. We're going to have our 15 minus 8 equals to 7. And then we go again. We take 7. We look for a number that's smaller than 7. 7 minus 4, which equals to 3. And then we're going to say 3 minus 2, which equals to 1, and then we put our 1. And then we come and take these numbers here, which are very important. These numbers here, right? So we're going to start from 32. We started subtracting from 32. We're going to write 32, 16, 8, 4, 2, 1. Is 32 part of the numbers? Yes. Is 16 part of the numbers we subtracted? No. Is 8 part of the numbers? Yes. Is 4 part of the numbers? Yes. Is 2 part of the numbers? Yes. As 1 part of the numbers? Yes, it is. And this is our final answer, which is 47. And then we can double check again if these numbers add up to 47, right? So remember, we add all the numbers where there is a 1. So we're going to go ahead and look for those numbers. We're going to say, because there's a 1 here, we're going to say 32. There's a 0 here, so we skip it. There's a 1 here, plus 8. There's a 1 here, plus 4. There's a 1 here, plus 2. There's a 1 here, plus 1. 32 plus 8 equals to 40. 40 plus 4. 44 plus 2 plus 1 equals to 47. So our answer is right. And then we're just gonna have one last example for this method, and then we move on to the other method. We will be converting 31 to binary. 31 to binary. Remember, from our powers of 2's, it's important for us to write that down first. We're gonna have 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Sometimes it's not necessary. You check the number you're converting and check. It's in this case, because we are converting 31, there was no need for me to write these numbers. But it's also okay. So we have 31. Subtract the number less than 31 here. 16, which gives us 15. We take 15. Subtract the number smaller than 15, which is 8, which gives us 7. We take 7 minus the smallest, which is 4, which gives us 3. And then we have 3 minus 2, which equals to 1. And then we write our 1. Then here, these will be our numbers. We have our numbers here. And then we go check. So we're going to start from 16. And I write 16, 8, 4, 2, 1. Was 16 part of the numbers we were subtracting? Yes. We write 1. Was 8 part of the numbers we subtracted? Yes. We write it as 4 part of the numbers we subtracted? Yes. Is 2 also part of the numbers we subtracted? Yes. Is 1 part of the numbers we subtracted? Yes. And now how can we check if our answer is correct? Sorry about that. How can we check if our number is correct? We go look for ones. underneath, and then we add. So we're going to add 16 plus 8 plus 4 plus 2 plus 1, which gives us 31. So our answer is correct. So this is 31 in binary. I hope you understand that method. And then we move on to the division method. So the division method works differently, but it still leads us to the same answer. So we're going to convert 31 using the division method. What happens with the division method is that we always divide by 2. So we're going to take 31, divide by 2, which gives, we don't need to know what it gives us, but we need to know if the number is divisible by 2 or not. If it's not divisible by 2, that means there's a remainder, which is 1. So we check 31 divided by 2. Is there a remainder? Yes. And then we write 1. What is 31 divided by 2? Sorry, actually we do need to know. What is 31 divided by 2? It's going to be 15. 15 divided by 2, there's a remainder, right? Which is 1. What is 15 divided by 2? It's actually 7.5. But we're not going to take 7.5. You will just take 7. 7 divided by... Let me just use this because it's a bit difficult. Seven divided by 2. There's a remainder of 1. What's 7 divided by 2? Equals to 3.5, but we're not going to take 3. We will just take... we're not going to take 3.5. We will just take 3. 3 divided by 2 equals to 1. The remainder is 1. Right? And then what is 3.2 divided by 2? Equals to 1.5, but we're not going to write 1.5, we write 1, which is 1 divided by 2, which now is the last one, and there is a remainder. And then from this we write our numbers in backwards. Here it's not going to be visible enough because we just have ones, but we start writing from the bottom up. So we write this number first here, then this one here, this one here, this one here, and this one here. And that is our final answer. We can use a different example. One of the examples that we did before, so that we see that it's still the same method. Not the same method, it still leads us to the same answer. Let us convert 47. Yes. Okay, so we're just gonna convert 47. We will be converting 47 to binary using that division method. So now we're gonna say 47 divided by 2. It's not divisible by 2, so 47 divided by 2 will have a remainder of 1. And then what is 47 divided by 2 is actually 23.5, but we take 23. 23 divided by 2, there's a remainder. 23 divided by 2 will give us 11.5, but we're not going to take 11.5, we take 11. Divide by 2, we get a remainder of 1 again. And then we have 11 divided by 2, which is 5.5, so we take 5. Divide by 2, which gives us 1. What is 5 divided by 2 is 2.5, but when we take 2 divide by 2, there's no remainder. What is 2 divided by 2 is equals to 1. 1 divided by 2, we get, there is a remainder, 1. And 1 is our last number. Remember, we start writing from the bottom up. So we're going to say 1, 0, 1, 1, 1, 1. We write this first, this second, this third, this fourth, this fifth, sixth, and so forth. And that's how we use our division method. So you can use a subtraction method or division method. You will just choose whatever it is that works best for you.